These are notes for section 5.2. Okay, so 5.2, page 254. 1 to 63 odd, 67 to 72 all, 75 to 80 all. So there are some problems. Up to about 18. Some more. There. Next page. Some more. 80. So here are those. And now the answers in the back. Section 2, yeah. So there's that. A little bit more. We had to go to 80, so you can see 80 there. Okay, so that should do it. Okay, so now we're dealing with negative exponents. So 3 to the negative 2, by definition, is 1 over 3 squared. So that's how you handle a negative exponent. So 1 over 9. Okay, 5 to the negative third, 1 over 5 thirds. 5 times 5 times 5 is 125, so 1 over 125. 13.5 y to the negative 2, that whole thing goes in the denominator as 1 over 5y squared. 5y times 5y, 25y squared, but it's in the denominator. 19, the rule is I'm supposed to subtract the exponents, so 5 to the 1 minus 3 is negative 2. 5 to the negative 2 we now know means 1 over 5 squared, 1 over 25. 25, 2x to the 7th over 2x to the 4th. Even though it's a more complicated base, these two are the same bases, so I can just subtract the exponents. 7 minus 4 is 3, so 2x cubed, that's 2 cubed times x cubed, 2 cubed, 2 times 2 times 2 is 8, and x cubed is just x cubed. Okay. Or you can think of it as 2x times 2x times 2x, 8x cubed. 31, I subtract the exponents. 2 to the negative 5 minus 3 is negative 8. So that's 1 over 2 to the 8th. You can use a calculator, but 2 to the 8th power is 256. 2 times 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 2, 256. 37, 3xy to the 4th power. Remember, that's like 3xy times 3xy times 3xy times 3xy. So 3 to the 4th power comes out to be 81. X to the 4th, y to the 4th. 43, blah, blah, blah to the negative 2 means make it a positive 2 in the denominator. So 1 over 7y cubed squared. 7 squared is 49. Y cubed squared, I multiply 3 times 2, so y to the 6th power. 47, y to the 7th times y to the negative 10. Add the exponents. 7 plus a negative 10 is a negative 3. And y to the negative 3 we now know means 1 over y cubed. Okay, 53, y to the 7th over y squared to the 8th. First, I'll combine these. 2 times 8 is 16. So y to the 7th over y to the 16. I subtract. 7 minus 16 is a negative 9. Y to the negative 9. Put this in the denominator as 1 over y to the 9th. In 57, I multiply these. X to the negative 2 times 3 is x to the negative 6. Okay, and then I'm supposed to subtract. So x to the negative 6 minus a negative 5, that's negative 6 plus 5, double negative. So x to the negative 1, which I'm going to write as 1 over x to the 1. But if it's x to the 1, you normally just write x. Okay, 63, I clean this up, clean this up, clean this up. So a to the negative 2 times 3 is negative 6. A to the 4 times 2 is 8. A to the negative 3 times negative 2 is 6. Okay, then I combine these two. A to the negative 6 plus 8 is a squared. And then a squared over 8 is 6. I subtract the exponents. 2 minus 6 is negative 4. 8 to the negative 4th means 1 over 8 to the 4th. All right, then we have some scientific notation problems again. Now, these numbers are very small. A very small number will be indicated by a negative exponent on the 10. So once again, pick up the decimal. of 0.000048. Move it so that you get a number between 1 and 10. That would be at 4.8. That's a move of 1, 2, 3, 4, 5 spaces. So 4.8 times 10 to the negative 5, because that's a small number. Now 35 is a larger number, so that's like last time. It's going to have a positive exponent. So 35, move back 1 space to get 3.5. That's a number between 1 and 10. 3.5 times 10 to the first. 72, 0.0009. Move over 1, 2, 3, 4. 9 times 10 to the negative 4. Okay, 4.23 times 10 to the third power. That's like last time. Move 3 spaces to the right. 1, 2, 3. Might have to add a 0. So 4,230. Okay, 8 times 10 to the fifth. Make it a larger number. So put down the 8 point and move 1, 2, 3, 4, 5 spaces. Notice I padded with all the zeros. 800,000. Number 84.2 times 10 to the 1. Just move her 1 spot. 42. Okay, then 79. 4.2 times 10 to the 0. There's 2 ways to think of this. Okay. First, I can say I moved the decimal 0 places, so it stays 4.2. Okay. But that also leads us to show that 10 to the 0 must be 1, because 4.2 times what number would still be 4.2? Well, that would be 1. So that means 10 to the 0, or anything to the 0 power, is defined to be 1. Okay, so this is section 5.2.